Hello, everyone. So today we are going to talk about regression. This is lesson 5? No, lesson 6. So by the end of the lesson, you will be able to write equations of best fit lines using linear regression. You will also be able to use the correlation coefficient to analyze the fit of the line. Now, let me just talk to you for a minute about some key things. Yesterday's lesson, we were not being precise. We found a line of fit or a trend line, but everyone's could have been a little different. It was not precise. Today, we are going to use computer technology to create the best fit line. This is going to be precise. Okay, so I just want to make sure you're clear on the difference between what we did yesterday, where we were like kind of hand drawing a line. Everyone's might have been slightly different. Answers were not precise. And today we're going to be very precise because the computer is going to do the work for us. Okay, so that's the big difference between yesterday and today. Other than that, though, we're talking about the same things. We're talking about scatter plots. We're talking about a line that models the data. We're going to write the equations, all that good stuff. Okay, so this kind of is like what I just mentioned, but let's talk through it. You've learned how to find a line of fit by hand from a scatter plot. We've discussed how everyone might have slightly different lines of fit. However, graphing calculators utilize an algorithm called linear regression to find a precise line of fit called the best fit line. The calculator will compute the data, write an equation, and give you the correlation coefficient. Now, the correlation coefficient is a statistical measure that tells you how closely the equation models the data. Okay, and we'll get more into that in a minute. The correlation coefficient will tell you if your correlation is positive or negative, which you would be able to tell just by looking at the graph anyway, like you did yesterday. You can tell whether it's got a positive or negative correlation. It will also tell you how closely the equation is modeling the data. The closer the correlation coefficient is to 1 or -1, the more closely the equation models the data. So for example, you're most likely going to have a decimal. I don't know, you would have to have data that is perfectly in a line in order for you to have a coefficient of 1 or -1. Well, typically in a scatter plot, it's not a perfect line. So you're probably going to have a decimal that is between 1 and -1. Okay, well, if your decimal is like 0.92, that's pretty darn close to 1. So that is a very good model of the data. Or if it was -0.95, that's a very good model of the data. However, the closer your decimal gets to 0 from either direction, the less closely it models the data. So like if we had, oops, didn't mean to do that. If we had, a 0.5, that's kind of like, meh. It's an okay representation. It's medium. It's not great. It's not awful. Okay. That would be -0.5. If we had 0.3, not so good. Okay, so we're not going to use any hard and fast rules about when is it great versus good versus medium versus bad. We're not going to have any hard and fast rules. Just know that it's kind of on a scale, that the closer it is to 1, the better the model. The closer it is to 0, the worse the model. Okay? All right, so let's take a look at an example. Here we have a table of values of gas prices in certain years at a certain gas station in Los Angeles, California. Okay, so that's our data. Remember, in a table, your top row is your input or your independent variable or your domain or your X. All of that kind of means the same thing. Your bottom row is your range or your output or your Y value, and so forth. Okay, so what we're going to do today is we're going to enter a table on Desmos, and I'll show you how to do that in a minute. So all you're going to do is copy the information from the data they give you into a table on Desmos. Make sure you're typing carefully, because if you mistype something, then you have changed the data and you're not going to get the same answers that everyone else is getting. Then you're going to type this into Desmos. This is the linear regression equation. Okay. Now notice there's no equal sign, it's a tilde sign. And that tilde sign is found on your keyboard next to the number 1. Okay. All right. So again, that is by the number 1 on your keyboard. I think it's to the left of it. Now, what's important is what Desmos is going to give you. So remember, I said Desmos is going to do the math for you. You've got to type in the data. You've got to tell it to make a linear regression. But then it's going to spit out this box. And this box is full of good information. So for starters, it gives you your slope. It also gives you your y-intercept. Well, as long as I know my slope and my y-intercept, then I can write the equation of the line, which I do right here in number 3. Now remember, we're being precise today, so we're not going to round off any decimals. We're going to use the long decimals that they give us. Okay? We're not going to do any rounding. We're being precise. Okay, now the other pieces of information that are in this box are statistical information, some of which we're not ready to learn. You're not even going to learn it this year in Algebra 1, but you will learn it in a future math class. We are not going to worry about residuals, so you can ignore that. We are also not going to worry about r squared. You can ignore that. We are going to use the r value, and this is my correlation coefficient, and I'm going to abbreviate with CC. That is my correlation coefficient. Remember, I said it would always be a decimal between 1 and -1. Okay, so my correlation coefficient is 0.9978, which is super close to 1. So this is a great fit for the data. Now, why is that important? Why do we care how good of a fit it is? Well, if I use this equation from number 3 to make a prediction of, let's say, gas prices in 2012, the better the fit is, the more accurate my prediction probably is. It's still a prediction, so it may or may not come true. But we could say that based on the data, that is the best prediction I could get. If we had a lower correlation coefficient and said that my line isn't that great of a model, then my prediction for 2012 might be way off. There would be a way more chance of it being wrong. Does that make sense? So the better the model, the more accurate we could rely on our predictions. The less closely the model, then our predictions might not be as accurate. Okay? They're still predictions, but you know what I mean. Okay, hopefully that all makes sense. So now we're going to try this. Number 1, we're going to do that on Desmos. So I'm going to do it on here on the video. If you want to pause and try it all at the same time, great. Or if you want to watch this video and then try it on your own, that's fine too. So we've got Desmos. Now let me show you what that looks like. All you're going to do is go to www.desmos.com. You don't need a code. You don't need an assignment in Google Classroom. You just go to desmos.com. And it will look like this. And you're just going to click Graphing Calculator. And it's going to open up this. Okay. So to make our table, we're going to hit plus. And it gives you these options. And we're going to say table. So we're adding a table. Notice that the table automatically populates with X1, Y1, because it's my first table, okay? So I'm gonna just populate my X values in here. And then I'll go in and populate the corresponding Y values. And there's my table of data. Okay. Now, you might be saying, well, why isn't it graphing on here? Well, my window of my graph is only going from -10 to +10, but we've got inputs from 1992 up to 2010. You don't really need to see it, but if you want to see it, just zoom out over here, the plus sign, until you start to see your point, and then you can kind of drag it and center it, and then you can sort of zoom back in until you can see the data points. So now I've got my data points in my viewing window. And now in box 2, I'm going to type my linear regression formula. Now with Desmos, when you type Y1, it automatically makes that 1 a subscript. So you don't have to do any special keystrokes for that. So I'm just going to do Y1, then my tilde, I've got to hit my shift and that button to get my tilde symbol, mx1 plus b. Now, before we talk about what it gave us, make sure that your subscripts in your table and in your equation match. So if your table is x1, y1, then you're going to use x1, y1 in your equation. If your table would happen to be x2, y2, then you would want to use x2, y2 in your equation. So your subscripts in your table and your equation need to match. Okay, just an FYI. All right, so again, we're not worrying about r squared. We're not worrying about residuals. We've got an r value of 0.8434. We've got a slope of 0.250685. And we've got a y-intercept of -493.953. Okay, so let's go back to our notes here and put in our information. So our slope was 0.250685. Our y-intercept was -493.953. And as long as I have my slope and my y-intercept, now I can write my equation. So y equals, and remember, this is kind of tedious, but we're not rounding. There's my equation, okay? Then my correlation coefficient, which is my r value, was 0.8434. So that's not as high as the other one, so it's not as good of a fit, but it's still a pretty good fit. 0.8 is still pretty close to 1. So I'm just going to say pretty good. Yes, it's pretty good. Okay, and that's it. That's how we do this. Okay, before I let you go, I want you to complete 2 through 6 on your own, but I did have a typo that I want to clarify. In number 3, scratch out this part of the directions. It had originally said let x be the number of years since 2006. We're actually just going to use the years, so scribble out that part. And then in number 4, we're also going to scribble out that part of the direction. And some people ask me, do I need to change my percents to decimals? No, you can just leave it as 14.4 and 15.8, because if we were actually printing this graph, you would just label in your x-axis that it was a percentage. And so that's okay. You can just leave it as that. And that way we'll all be consistent. Okay, so go ahead and complete those for homework. And then tomorrow we will be in person, well, in person online, we'll be live, and we will go over this and talk about some things. Today, if you need me, just shoot me an email and we can hop on and do a Google Meet if you need me. Okay? Have a great day.